Mars. The red planet Mars has long fascinated humanity, both as a neighboring planet and as a subject of speculation regarding the potential for life beyond Earth. Known as the red planet, Mars is characterized by its striking reddish appearance, which is primarily due to the iron oxide, or rust, that coats its surface. This unique coloration has inspired numerous myths, stories, and scientific inquiries, making Mars a central figure in both astronomy and popular culture. Distance and position: Mars is the fourth planet from the Sun, positioned at an average distance of about 228 million kilometers, or approximately 1.52 astronomical units. This distance makes it the second closest planet to Earth, after Venus. The journey of sunlight to Mars takes around 12.6 minutes, which plays a crucial role in the time it takes for signals and data to travel between Earth and missions on Mars. Terrestrial characteristics: like the other terrestrial planets, Mercury, Venus, and Earth, Mars is composed primarily of minerals containing silicon, oxygen, metals, and other elements that typically form rock. This classification signifies that Mars shares several geological features with Earth, including mountains, valleys, and canyons. However, Mars is the second smallest planet in the Solar System, with a diameter of approximately 6,707 kilometers. To put this into perspective, Mars is about half the size of Earth, yet its surface area is comparable to the total land area of our planet. Geological features and surface conditions: Mars is often described as a dusty and cold desert world. Its thin atmosphere, composed mainly of carbon dioxide with traces of nitrogen and argon, creates a harsh environment. Despite these challenges, Mars showcases remarkable geological features. It has the largest volcano in the Solar System, Olympus Mons, which towers about 22 kilometers high, almost 3 times the height of Mount Everest. Mars is also home to Valles Marineris, a canyon system that stretches over 4,000 kilometers and reaches depths of up to 7 kilometers, making it one of the largest canyons known to humanity. The evidence of ancient geological activity on Mars suggests that the planet was once more dynamic. Signs of heavy flooding and river-like features indicate that liquid water flowed across the surface in the past. Currently, water primarily exists as ice in the polar caps and as subsurface ice, with indications of briny liquid water beneath the surface in some regions. This discovery raises the possibility that Mars may have once been capable of supporting life. The polar ice caps and water: Mars polar regions feature ice caps composed of water and dry ice, frozen carbon dioxide. These caps expand and contract with the changing seasons, revealing the planet's climatic variations. The presence of water ice is particularly intriguing, as it serves as a vital resource for potential future exploration missions. The possibility of extracting water from these ice caps could facilitate human habitation on Mars and support long-term missions. Atmospheric conditions and temperature variability: Mars' atmosphere is significantly thinner than Earth's, providing limited protection from space radiation and meteorite impacts. Average surface temperatures on Mars can be extremely cold, ranging from a balmy 70 degrees Fahrenheit, about 20 degrees Celsius, at the equator to a frigid 225 degrees Fahrenheit, 143 degrees Celsius, at the poles. These temperature extremes are exacerbated by the planet's thin atmosphere, which allows heat from the Sun to escape quickly. The axial tilt of Mars is about 25 degrees, similar to Earth's axial tilt of approximately 23.5 degrees. This tilt is responsible for the seasonal changes observed on Mars. However, because of its thin atmosphere, Martian weather patterns differ markedly from those on Earth, often resulting in massive dust storms that can envelop the entire planet. A day in a year on Mars: Mars completes one rotation on its axis approximately every 24.6 hours, which translates to a Martian day lasting about 24 hours and 37 minutes. This similarity in day length contributes to the feasibility of conducting experiments and studies on Mars using Earth-based timekeeping methods. A year on Mars, however, is considerably longer. It takes about 687 Earth days to complete one orbit around the Sun. This extended year length affects the timing of seasons, which last nearly twice as long as those on Earth. Mars exploration and future prospects. Mars has been a focal point for exploration missions, with numerous spacecraft and rovers sent to study its surface, atmosphere, and potential for life. NASA's rovers, such as Spirit, Opportunity, Curiosity, and Perseverance, have provided invaluable data, revealing insights into the planet's geology and climate history. Perseverance, in particular, is actively searching for signs of ancient microbial life and collecting samples for potential future return to Earth. The prospect of human exploration of Mars is also becoming increasingly realistic. Various space agencies and private organizations, including NASA and SpaceX, are planning missions to send astronauts to the Red Planet within the next couple of decades. These missions aim not only to explore Mars further but also to establish a human presence, paving the way for potential colonization. Conclusion: Mars, the Red Planet, continues to captivate our imagination and drive scientific inquiry. Its intriguing geological features, potential for past and present water, and the possibility of supporting life make it one of the most exciting places in our solar system. As we expand our understanding of Mars through exploration, we move closer to answering fundamental questions about the existence of life beyond